Awesome. So we can start. Thank you so much for coming for the session. How green is my OpenTelemetry collector? So I was about to present this talk with Adriana. She's amazing. She is a principal developer advocate at Dynatrace, and she is an expert in OpenTelemetry. I wish she could be here. Due to some issues, she could not be here, and we are going to miss you, Adriana. A little bit about me, I am Nancy. I am a CNCF ambassador. I was a part of Tag Environment Sustainability, which is all about sustainability in tech. And with this, I worked as DevOps engineer, then I worked as developer advocate with Gitpod and LocalStack. And other than work, I love cats. I love traveling. I also love making illustrations, so that's about me. You can scan the QR code to know more about me or get connected with me. So let's get started. Global warming is real. I just want to ask, can you just raise hands? Do you think this is true? Whether it's about the rising sea level, whether it's about the climate change, the drastic changes, we know that it's for real. I have a question for you in the audience. Does anyone know that which country is moving its capital city due to climate change concern? Any guess? That's true, Indonesia. So Indonesia is moving its capital city, Jakarta, to a new capital city due to climate change, and this is concerning. It's a huge thing if a whole country has to move its capital due to rising sea level. Then what percentage of global carbon emission is the IT sector responsible for? Well, the number is 2% of global carbon emissions. It looks like a small number, but the catch is it's going to increase by 12% by 2040. And this is a huge number. So we as an engineer are responsible for this. And then that's bring us the question that how tech and environment are correlated. So we know that IT sector is responsible for 2% of global carbon emissions, and it's going to increase in future. Then data centers rank in the top 10 of water-consuming industrial or commercial industries. This applies to both indirectly to generate the electricity that the data centers need to operate, and directly as a liquid coolant to dissipate the heat generated. So it's a significant numbers. And then keeping our systems observable has an impact on the environment. Like whatever tech we are running on the cloud, everything has an impact. And that's why tech and environment, we need to think about tech and environment. So for this talk, we picked up OpenTelemetry. Have you worked on OpenTelemetry? Awesome. So OpenTelemetry is something which almost everyone has been working on. So there was a problem. The question was by developers and operators, for all those people who are new to OpenTelemetry, the question was that why can't we have an open standard that supports the traces, metrics, and logs and work for all the vendors? And due to this question, to answer this question, OpenTelemetry was born to provide a single set of SDKs, to have a standard format, and support for traces, metrics, and logs. So how about we start with OTel Collector on Kubernetes? But before this, why are we even tweaking the collector? Let's first understand that what exactly is collector and what it is doing. Now, OpenTelemetry is a vendor-neutral agent which is used to ingest. As you can see, the receiver, we have the OpenTelemetry receiver, host metrics receiver, Kafka receiver, and then we have a processing. So, and in this processing, we have the connectors and extensions. And then in the end, we have the exporters. So this is how the OpenTelemetry collector looks. And now the answer to the question that why do we need to tweak the collector? So the whole process of ingesting and processing and basically exporting, it uses up the energy. And this is just about one collector. And in an organization, we definitely have multiple collectors. We have fleet of collectors. So that means if one collector is consuming energy, just imagine the number if we sum up with the whole, the fleet of collectors. So optimizing one collector can save energy, but optimizing multiple collectors compounds the savings for even greater efficiency. Then optimizing, so again the same thing, we are going to optimize the multiple collectors. Now there are many ways to deploy collector. For our presentation, we are just going to focus on the collector which is deployed on Kubernetes. But before this, we are going to understand that what exactly OTel Operator does, because OTel Collector deployed on Kubernetes is managed by OTel Operator. So let's see OpenTelemetry Operator. So it's a Kubernetes operator that is responsible for the two tasks. Now, one is like injecting and managing the configuration of auto instrumentation in your Kubernetes pods. And the second one is managing the deployment and configuration of your OpenTelemetry collectors. So this is something which, these are the two tasks which our OpenTelemetry operator is doing. And OTel Collector also includes a component called Target Allocator, and we are going to discuss about that in the next slide. The main task of the Target Allocator is, it's basically used to decouple the service discovery and the metric collection functions of Prometheus so that we can scale it independently. Now for this talk, we are just going to leverage the service discovery. Now by service discovery, we means, so we are referring to the automatic detection of certain Prometheus custom resources in the Kubernetes clusters, which is service monitor and the pod monitor, which you can see. Now these CRs don't do any scraping themselves. So instead, they act like a watch list that tell Target Allocator what services or pods should be monitored. So Target Allocator reads, so here Target Allocator reads these watch lists, and they add corresponding scrape jobs to the OpenTelemetry collectors. So this is what Target Allocator is doing. Now, so that is a bit about OpenTelemetry, like what we have done, what we are using, OpenTelemetry Collector, Operator, Target Allocator. But now let's come to the main thing, which is some tools and practices at our disposal. So what we are going to do in our presentation, we are going to scale the Kubernetes pods. We are also going to touch upon metrics-driven optimizations, and then lastly, about green reviews. So we are going to dig this one by one. This is our proposed setup. This is something which Adriana and I worked upon. So we have this Kubernetes cluster. The plan was basically to deploy Kepler to collect the energy consumption data for our collector, and then use this information to tune the collector. So we basically did experimentation to understand that how can we tune the collector and what could be the best way to basically configure our OpenTelemetry collector. So as you can see, this OpenTelemetry collector receives the telemetry data from Kepler application, and then it sends it to the observability backend. You can also have Kube Prometheus stack. That is something which you can have, but if you already have your own observability backend which supports the Prometheus metrics, then you can use that. And finally, green reviews would give us an overall sense that how green our whole setup is. Now let's dig into the first part, which is scaling the pods. Why do we want to scale up the pods? Now, that's the question, that why do we want to scale up the pods? Well, Kubernetes is amazing, but then it lets us specify the number of replicas. We can have multiple pods to basically have our system more resilient. But then again, it eats up a lot of CPU and memory. So we want to make sure that the more resources utilized by our pods, it's going to have the more energy they use, which means that you want to maintain a balance between running the optimal number of pods and also so that your system is performant, resilient, but you also want to be concerned, but you also want to make sure that it doesn't consume a lot of CPU and memory. So again, the resource usage is equal to energy usage. Scaling pods based on usage saves energy. So we have tools that can help us with this, which is Kube-Green. So are you folks aware with Kube-Green? Okay, so we see number of people who are aware with Kube-Green. Again, so Kube-Green is Kubernetes operator. So when we started, Adriana and I, when we started working with this project, we thought that Kube-Green is going to help us with our collector as well. We're going to talk about it more, but yes. So Kube-Green is a Kubernetes operator that automatically shuts down your Kubernetes resources when you don't need them, and it restarts when you do. So this helps reduce the carbon footprints. Now, and some adopters have reported a 30 to 40% of savings on monthly cloud cost. So this is important. Now the thing is, this is how your Kube-Green config looks like. So we have this leap info resource in a namespace called OpenTelemetry. So all the resources under the namespace will basically are using Kube-Green, and if we see the spec over here, it says that sleep at 16:51 and then wake up at 16:54. So during weekdays, during this particular time, it will basically, it's going to sleep, like all your pods will shut down, and then it will wake up at 16:54. You can also further filter by labels and even resource type and name. So this is how your Kube-Green sleep info config looks like, pretty simple. And you can basically have this in your infrastructure. Then we talk about Kube-Green and OpenTelemetry Collector. So when Adriana and we started working on this, we thought that it's going to work for the OpenTelemetry Collector, but it did not. First of all, we noticed that Kube-Green worked on all the pods running in our example repo, except the OpenTelemetry collector pods. We thought that maybe it's because our collector was configured to deploy a stateful set, but then we realized that Kube-Green works for both stateful set and deployments. So after scratching our heads for a bit, we realized that what was happening. So basically, if you remember, we talked about OpenTelemetry operator. So basically, Kube-Green thought that OpenTelemetry collector is basically managed by OpenTelemetry operator, so it ignored the OpenTelemetry collector pods. But then again, we realized that maybe we don't need to do that. We don't need our replicas down to 0, because even in the non-prod environments, whether it's testing or dev environment, because you probably want it to be running so that you can have your telemetry to help inform better decisions or if anything is going wrong. So you do not anyways need it. So what can we do? So then we have horizontal pod auto-scaling. This is something you can do with your OpenTelemetry collector. So it's a configuration which is built in the OpenTelemetry operator, which is managed by collector config. And it can scale up or down based on the CPU or metrics usage. And it gets resource utilization via metrics server running in Kubernetes. So this is how the configuration looks like. Now, to config the autoscaler in the OpenTelemetry resource, you need to specify the maximum and minimum replicas, as you can see in the config. And you can also mention the target CPU utilization, which you need, and also the memory utilization. And then you can also put the resource limits. Over here, you can see that we have put limits on CPU and memory and the request. So this is how you can config your OpenTelemetry collector HPA config. Then we have metrics-driven optimizations. So why do we even want metrics-driven optimization? To work on something, if we want to improve something, first we need to measure it. So that's why we need to first measure that what's happening with the system so that we can take an action. So it provides insights into performance and the health of system. And we can also use metrics to understand the energy consumption. And high CPU and memory is equal to more energy. So this is something which we used, which is Kepler. Again, do you folks know about Kepler? Any of the, awesome. So we have like a couple of people who know about Kepler. It's a CNC project, it's open source, so you can go and contribute to this project. It's short for Kubernetes-based efficient power level exporter. It uses eBPF technology, and it monitors and optimizes the energy consumption in your Kubernetes environment. And also it exports Prometheus metrics, which enable users to analyze and visualize the energy consumption. So how do we run the Kepler? So you need to install Helm or Kubernetes. You can install it via Helm or the Kubernetes manifest. Depending on your setup, you may also need Kube Prometheus stack or any backend that supports Prometheus metrics. And then again, we have OpenTelemetry operator. In our case, we are using OTel Collector to scrape and process the Prometheus metrics. And also the OTel operator, among other things, is used to manage and deployment of the OTel Collector. Then we also have internal collector metrics, and Adriana, who was supposed to be here, she just released an amazing blog on this, on her findings about internal collector metrics. So maybe you can have a read for that as well. I can share the resources later on. So another tool that we have is OTel Collector. It emits its own internal telemetry. So we can leverage this to basically see that what's the CPU and memory usage. We can do this by capturing and analyzing the memory consumption metrics. Now that we have all this information, which we have, now let's see that how we configure the collector to leverage the Kepler and internal collector metrics. So I'm going to keep it very short because we are short on time. So this is how Kepler Service Monitor looks. So Kepler already installs a copy of the service monitor. However, we are overriding the service monitor so that we want to exclude some metrics that we don't need. So this is how you can override. And then we have, this is OTel Collector Resource Target Allocator, which we talked about. So over here, we have enabled the target allocator. And then we have Prometheus custom resource. We have enabled that as well. Then we have OTel Collector Resources, the receivers. So this is how you can define in your config. Then we have Prometheus. It ingests the Prometheus metrics, and it also scrapes the collector metrics. Then we have Kubernetes cluster over here. As you can see the configuration. It collects basically the cluster level metrics and emits the events from the Kubernetes. Then we have kubelet stats. This does the same thing as Prometheus, kubestat state metric exporter. So it pulls basically the node and the pod and the container and volume metrics from the API server. Then we have, this is how the OTel Collector resource for processors looks like. So we have this, which is for transforming the transform metrics processor. It basically mapped the Prometheus field naming conventions to the OTel naming conventions. And then we have Kubernetes attributes over here. And this is Kubernetes processor. So it enriches the trace and the logs and the metrics and with the Kubernetes attributes. Over here, again, this enriched the trace logs metrics specific to our KX pipeline. And then finally, we have resource attribute. It adds cluster name to our telemetry. So then we have pipelines. So we have like two pipelines. The first set of pipeline is for the application. And the second set of pipeline, these are specific to our Kepler setup. We have separate pipelines so that we don't pollute the OTel data. And then we don't want Kepler data polluting our regular application pipeline data. That's why we have configured in this way. And also, like, you can basically scan this QR code. We have the repo on GitHub, and you can basically have a look at different configuration which we did. Awesome. So let's come to the green reviews. Now, another item we explored a bit were green reviews. It's not a mitigation process. If you want to know more about it, you can also join the CNCF Slack. We have a whole team of green reviews, which does it for different open source projects. Like Falco, we are in process of doing it with OpenTelemetry. Like last week, we discussed that if we can do the green reviews for OpenTelemetry, it would be awesome. So we are in process of doing this. So what exactly green reviews does, it exposes the energy consumption of projects after each new release so that we can monitor that what's happening with each new release, and then we can take better decisions. And the main goal is for the energy consumption to not go up with each release. Awesome. So putting this into the practice, what we tried two things, splitting up the OTel collector into two, and also we tried building a custom collector distribution. So we tried splitting up the OTel collector in two, like one for the Kubernetes telemetry and the other one for the application telemetry. So this is what we measured. These are the different metrics which we measured over here. And then this is what we realized. So as you can see, there are two separate collectors, and the combined energy output of split collectors has higher energy output than single collector. So the green line is basically the single collector, and the white and blue lines are the split up collectors. So basically, looking at each of these outputs, like the individual collectors via single collector, you see that energy output of individual collectors is lower. And ratio shows, so here's the ratio which we calculated, and the ratio shows that splitting up the collectors into two, basically, it was the worst. It just did the worst thing. And then when we measure the memory, so it almost looks about the same. And then let's talk about the custom collector versus the contrib. So the blue line looks generally better. And the ratio shows that our custom collector is generally the better. And memory shows a noticeable difference too. The custom collector is basically the blue line, so memory consumption is also less. So now what? So we have the tuning tips. Use metrics to guide you. We just, like measuring is the first step, basically to know that what we can tune. So Kepler and internal collector metrics can help. And then custom collector build uses less memory, as we have seen in our small experiment, and therefore less energy. And you can limit the replicas whenever possible. You can limit the telemetry emitted to reduce demands on your memory and CPU. So these are the lessons learned. Like, it's not a perfect solution, but like what we figured out is you need to experiment and test your assumption. So whatever infrastructure you have, not even the OpenTelemetry, like whatever you're running on, you can have Kepler and you can have metrics which can guide you that what configuration changes you can do to reduce the carbon footprint. And then we realized that don't change too many variables at once. You can try changing few variables and basically compare that what works the best. And then again, don't rely on just one test. We kept using different tools, Kepler, Kube-Green, then HPA, then we tried scaling up and down. So these are the different things which you need to experiment. And tuning is never done. Tuning is hard and requires a lot of patience and experimentation, so you cannot expect the miracles in first day. So you need to basically experiment a lot. And we just realized there's a huge learning curve. Like, we had to learn a lot of tools like Kepler, Kube-Green, and then we have like internal OpenTelemetry metrics. So it definitely requires a decent understanding of all the tools. So it's a huge learning curve. And you cannot expect a quick fix. You need to experiment, and you need to see that what works best for you. Then taking it to the next level, we have different things. You can use build packs for greener container builds. You can choose greener data centers. Sweden has the greenest data center, so we can learn something from them, that what are they doing the best. Then you can use kube cost to monitor and reduce your Kubernetes spend. So when you're using, and it gives a motivation when you are trying to reduce your carbon footprint, you can basically see that how is it basically you're reducing your Kubernetes spend. And then again, it gives you a better motivation. Then we have, you can scan the QR code. We have a huge sustainability landscape. We have different tools which you can basically experiment with. And then we also did interview Henrik, who is there in the audience. He helped us a lot, and he also gave a talk in City, Washington regarding the same thing, green engineering, which has been amazing. I was watching that on my flight, so you can check that out. He says that identify the working hours of environment to turn off application during night hours. So yes, definitely use Kube-Green, which can help you in this. Then Christina has been the Tag Environment Sustainability Tech Lead, and she says that regularly audit everything that is running. Then we have Yushin. She has been into ML, and we have like a lot of things moving towards AI, so definitely good suggestion. GPU waste is your biggest leak, so fix the pipeline. Most teams use only 20 to 30% of their GPUs. Then we have two folks from PTC group who says reducing carbon footprint is not a sunk cost, but can actually help companies reduce the expenses. Then we have different resources. We have resources for Kepler project. We have CNCF landscape. You can also, I'm not sure if I mentioned this, but you can also join the Green Reviews team. You can find if you scan the CNCF Slack channel, which is in the end, you can find, and if you type Green Reviews, you can find the Slack channel and you can join it. We have regular meetings once in a week, and then you can be a part of it if you're interested in optimizing the carbon footprint for your project. Again, this is the shameless self-promotions of Adriana. She has an amazing podcast, Geeking Out podcast. I was a part of it. Was there anyone else who was part of it in the audience? Okay, I thought. Okay, awesome. So again, these are the different things by Adriana. She has a fundamentals of observability with OpenTelemetry on ORally, which is huge. And then again, that's a QR code to join the OTel community in Denver, US, which is, I think, went anyways. So you can join the OTel community. And then this is about me. I started Women in Cloud Native community a year back. and it has grown a lot. Like there are 2,000 plus members over different platforms, so it's huge. We also did a meetup in London, and almost 90% people were new. So it has grown a lot, and it's great. So please feel free to join if you want to mentor. And then I'm also looking for new job opportunities, so feel free to connect with me. And that's the collection of my talks and work. Thank you.